Let's take a look at some elements of a graph that would make it a quality graph. First, at the top you'll notice you'll have a title. Your title should be descriptive, something that describes what your graph is going to show. Just the word graph is not a good title. Next, you'll notice on the x-axis, the one on the bottom, this is where you're going to locate your independent variable. On the y-axis, you're going to have your dependent variable. You should describe what those independent and dependent variables are with a word or two. Next to those, in parentheses, you'll notice you'll have your units. Your units are what you use to measure. Did you measure in centimeters? It would be cm in there. Did you measure in millimeters? Then mm. Degrees Celsius? Show that. Whatever your units are, you want to locate them so you know what your numbers are on your x and y axis. Notice, you do have to have numbers to graph something. If you use something like light and dark, you're going to have to create a number scale to show the difference between light and dark. On your x and y axis, you'll have numbers. One of the key aspects of these numbers are that there's an equal distance in between each of these numbers. If there's not an equal distance between the numbers and consistent intervals, it becomes difficult to read and hard for the reader to truly understand what your graph is trying to communicate. Of course, you'll also have your data. But when you put your data in, should you set it up as a line graph or as a bar graph? To answer that question, you have to ask yourself this: can you interpolate and extrapolate data? If yes, then it's a line graph. If no, then it's a bar graph. But what does interpolate and extrapolate mean? Let's take a look at an example to see if we can really understand the difference in interpolating and extrapolating. Let's say we did an experiment and we measured different amounts of fertilizer and saw how high our plant grew. We measured it at 2 grams, it grew 10 centimeters, 4 grams grew 22 centimeters, 6 grams grew 28 centimeters, and 8 grams grew 40 centimeters. So we measured 2, 4, 6, and 8 grams for our plants, and we actually watched and saw how tall they grew. But what happens if we wanted to know how tall 3-gram fertilizer would grow? We didn't actually do the experiment, but can we estimate where it would be in our graph? Would the 3 grams between the 4 and the 6 and the 8, or the 2 and the 4? The fact that we know that the 3 grams goes in between 2 and 4, this means we can interpolate within our data, and therefore it's a line graph. Let's look at an example where you can't interpolate data. Let's say instead of doing fertilizer amount, I did fertilizer type. So I took some plants and I grew them in Miracle-Gro, and in Miracle-Gro, they averaged a growth of 10 centimeters. In Southern States, they grew 22 centimeters. And in Grow-Mix, they grew 28 centimeters. But we never actually did the experiment with Uncle Billy's special mix. Where would Uncle Billy's do you think it would go? Does it belong at the end after Grow-Mix? Maybe in between the Southern States and Grow-Mix? Maybe in between Miracle-Gro and Southern States? We can't really tell where this would belong inside of our graph. There's no predetermined place because it's not on a number scale. So therefore, this is an example where we cannot interpolate information, so it's a bar graph.